Hello, today we're going to talk about pressure and volume in gases. Alright, a gas has indefinite shape and indefinite volume, so it's not fixed. So like with a balloon, you blow into a balloon air and it just takes up all that space. It pushes against the outside of the balloon, which creates pressure. The more you put in there until it basically explodes. But if you take, so say I have a can that has just one unit, or let's say 2 units of volume in let's say 16 ounces, why not? 16 ounces of a gas in one can. If I take what is in that can and I put it into one that's double the size, so 32 ounces, that same one that was 16 ounces, when I put it over, it becomes 32 ounces. It fills the entire container. It expands. That's how volume works when it comes to gases. So it doesn't have an indefinite volume. It expands in whatever container it's put in. It puts pressure against the outside of it. So a barometer measures atmospheric pressure. So atmospheric pressure is the force exerted by the weight of air in the Earth's atmosphere. It's also measured in 1 atmosphere. 1 atmosphere is 760 milligrams of mercury, or what is equal to 14.7 psi. All right, there's 3 properties of gases. The 3 properties are volume, temperature, and pressure. All right. So, and the number of gas particles in a sample. All right, of the properties, we're going to talk about volume and pressure today. So they have an inverse relationship. So as one increases, the other one decreases. So as your pressure goes up, that means your volume is going to go down. They're inversely related. If your volume goes up, your pressure goes down. If you think about it, it makes pretty good sense. So we're going to talk about Boyles Law today. So Boyles Law. Boyles Law is the pressure and volume of one is going to equal the pressure and the volume of a second container. So the actual definition is, at a constant temperature, a fixed weight of gas occupies a volume inversely proportional to the pressure exerted on it. So an example of this would be if I have a container and I have a weight on top of it. And let's say that's 1 atmosphere, which is how we measure it. And let's say this is 6 liters altogether. All right, now I apply 2 atmospheres of pressure onto it. This has to be 3 liters, because as the pressure goes up, the volume has to go down, and then this still equals 6. 2 times 3, 6. Then I apply more pressure to it. I apply 3 atmospheres. What would my volume be then? Well, my volume then is 2 liters. So the more pressure I apply, the volume goes down. Now if you look at it the other way, if I have 3 atmospheres right here and 2 liters, so I increase my liters to 3, that means my atmospheres have to go down. All right, we're going to do a couple examples of this now. All right, here's 2 examples of Boyles Law. So I have 9, and this is how I do them. I know I'm going to use Boyles Law, but even if I didn't, let's just say pressure, volume, temperature. Call them all one. Then pressure 2, volume 2, temp 2. Because there's more laws we're going to go over. So this is just me showing you the way I used to do it all the time. So I write down everything that I could possibly get. All right, pressure, volume, temperature, pressure, volume, temperature. Now, from there, I just write down what I get. So I have 9 milliliters. So 9 milliliters, that's a volume. We'll call this part my 1. So I have 9 milliliters. At a pressure of 500, so I have a pressure. All right, does it say anything about temperature there? No, but it still might. Now it says a new pressure of 750 milligrams of, I believe that's mercury, is applied, what is the new volume? So it doesn't say anything at all about temperature, so I just mark it off. I don't need temperature. So now I know I'm going to use Boyles Law because I have pressure, volume, and then I have a new pressure and a volume. So I do 500 times 9 equals 750 times x. And I solve, so it's 500, then divide by both sides by 750. That gives you 2, 3, 4. I think 7, 14, 21, 28. Nope. It is 6. I was close. 6. So our new volume is 6 milliliters, which if you use your common sense, the pressure went up, so the volume had to go down. So that does make logical sense of what it is. So let's go over to this one, and we're going to do the same thing. P1, V1, T1, then P2, V2, T2. All right, so I have a pressure of 1 atmosphere, call this 1, at a volume of 0.75. Now I know there's not going to be a T because that's everything I needed. And what's my new pressure at a volume of 0.15 liters? So 1 times 0.75 equals 0.15x. X equals 1, 2, 5. 5? Was that over? Yeah, should be 5. So my new pressure is 5 atmospheres. Let me check to make sure. And there we go. That is how you use Boyles Law. All right, this has been a video over pressure and volume in gases. Hope it helped.